Okay, good afternoon. We're just a few minutes before the 4 o'clock lecture set to commence for ENGG1003, just doing a video and audio check. We should be in the questions lectures channel. Just ask the question if the audio is okay in the channel. Anyone online out there want to give me a thumbs up that the audio is okay for our lecture this afternoon? We should be live on YouTube now. Wonderful, thanks, Rowan. And we should have the title page for Thursday of week 12 displayed. Excellent. Thank you. I'll go offline for a few minutes and we'll commence the lecture at 4:05. Thank you. Okay, welcome. It's 5 past the hour, so let's get this lecture underway. I'm watching the questions lectures channel in Discord, so if anyone's got any problems with the audio or the video, just let me know there. Thursday, week 12. Here we are. Final lecture of the course, and so for that reason, I've structured the lecture purely and simply around final exam preparation. I'm going to do my best to monitor the questions lectures channel as we go. So a little bit unlike most lectures that I've presented, I'm going to try and make this as interactive as possible. Because if the assignment is anything to go, it has taught me anything, and it's taught me a number of things. One thing is that it's impossible for us to guess every possible contingency. So to the extent that it's possible, I'm going to deliver today's lecture. Won't be a particularly long lecture, but the intent is to give you everything you need to be prepared for the final exam. If something comes up in the presentation today and you want to ask that question, it would be great if you can ask that question live. I'll do my very best to answer it live and hopefully head off any uncertainty there might be about the final exam. In saying that, there will be uncertainty about the final exam because I'm not about to give you a copy of the final exam here today. I've structured my hints in a very particular way, but I'm not about to give you a copy of the final exam. And in fact, it would be impossible to extrapolate from what I have here to an exact copy of the final exam. I'm deliberately withholding information because I want to know if you can solve problems. And to that extent, I want to give you a really clear sense of how the exam's structured. So I'm going to give you the truth, but I'm not going to give you the whole truth because the whole truth would be to give you the final exam. Not going to do that. So a little overview of what we're going to do today. I'm going to talk in the opening material about how the exam's going to be organised, a little bit about the mechanical details of when and how long it's going to take and such, and then some broad comments on academic integrity, particularly around the exam. But some of the comments I make there are broader than just the final exam. Then I'll give you an overview of the final exam questions, and there are 4 of them. Conditions apply, and I'll talk about what those conditions, but the best way for you to think about the final exam is that there'll be 4 questions. And then if there are any open questions, let's have them in the questions lectures channel. But as I say, very happy to monitor questions as we go. Haven't seen any questions yet, so let me know if there are any. And again, I'll do my best on the spot to answer those questions. But if I have to say, can't tell you that detail, I'll be straight up with you about that. So a little bit about the final exam. We find ourselves in a situation that the ideal setting for the exam would be a massive room with 700 seats. At each seat is a computer that's got PyCharm installed and that allowed us to have an exam which is open book, bring your materials, have materials online, 2 screens, the most perfect IT setup that you can imagine, and we run the exam in that way. It's not going to be run in that way. What we have is an exam which all students do at the same time, modulo a few students who have got alternative arrangements being made. The exam's done on Blackboard. It's an open book exam, and it takes and you have 130 minutes to complete it. It counts for 35% of your overall course grade in the course. So it's an online exam. So in many ways, it'll be similar to some of the assessed labs in the midterm quiz. So you get a copy of the questions and you get a certain amount of time in order to upload your solutions to Blackboard. What distinguishes it from earlier assessments is that all students in the class will see the same assessment at the same time. So there won't be this staggering of the questions that we've had in the assessed labs. So all the class gets to see the same questions at the same time. That's the main difference. That there's no staggering. Otherwise, all students get to see the same. So in that sense, it's most like the midterm quiz in which the whole class got to see the test at the same time. So in terms of organisational details, being an open book exam works for this course really well. I'm really big on what you might call authentic assessment. So if I love to assess students in ways that are realistic, given the nature of the content. And for this exam, for this course, an open book exam is perfect. That means I'm assuming that you have access to the lecture notes, the lab sheets, any notes you've taken, marked up copies of the lecture notes, textbooks, study guides, pre-existing Python code that you've written that's been posted in Discord, any pre-existing internet resource. That's great. I'm assuming you've got access to that. And what that means is that we've written the final exam on that basis. So the things that are not permitted are any assistance from friends or colleagues or fellow students or your mates, and what's also not permitted is any active participation in online forums such as Discord. Like you can't post a question in Discord which is saying I'm stuck on question 2, can someone help me? That's not permitted in the final exam. So as I say, we've written the exam assuming that everyone's got access to all the materials that have been presented in the final, all the resources that have been presented in the course. But you're not allowed to discuss them with anyone. So there's been a question posted in Discord. So all the 4 questions were requiring upload some written Python code. No, I'll talk about the structure of the 4 questions. 3 of the 4 questions will, Shani. So, but not the first. But before I talk about the structure of the code, the structure of the exam, and thanks for that question about whether all the questions will require uploading some Python code. Some will, some won't. First question won't. I'll get to that in just a few moments because it's a great question. A few comments about academic integrity. So what I'm talking about here is ways in which students can get assistance either by colluding or plagiarizing someone else's code or posting a question to some online forum around, how do I solve this question? I'll be really clear. I'm not interested in if your mate can solve a question. I'm not interested if you can work with your colleague to come up with a joint solution, because most of the questions involve some form of Python code upload, and those questions will be manually graded. If, for example, you were to work with your mate to come up with a joint solution, and it's surprisingly easy to detect those joint submissions. So we detected a few of those in grading the midterm quiz, for example. I'll have comments to make about the midterm quiz after today's lecture, but If you think you got away with it, maybe you did. Maybe you did. Maybe you worked with a mate and you come up with a joint solution to a question and you posted it for the midterm quiz and you think, that's good, got away with that. Maybe you did, maybe you didn't. Maybe you're one of the group of students that we're referring to the Student Academic Conduct Officer for code, which is not only wrong, but has bugs in it and is very distinctive. And it clearly looks like that code's been written by 2 or more people operating in collusion. That's in violation of the Student Academic Integrity Policy, and we're obliged to refer those submissions to the Student Academic Conduct Officer for as a referral to see what their assessment is. I spent a few minutes today reviewing the Student Academic Integrity Policy and the Student Conduct Rule. They're far from pleasant reading. The consequences of academic misconduct are severe or can be severe. They can result in grades being set to 0 for assessment items. They can ultimately lead to failing the course, suspension from the course, from the program, from the university. I wasn't involved in teaching this course last year. Brenton was, and my understanding is that there were students that were excluded from the university as a result of academic misconduct in the course of this ENGG1003 last year. Unpleasant topic to talk about, but I want to be really clear. The assumption is that when you press submit on an answer in the final exam, it's your work. It's not the work of you and a couple of mates sitting in a room doing the final exam. Of course, we can't tell that. All we know is, the assumption is that you're doing the work independently. We can't know for certain, but the nature of the assessment, the authentic assessment here, when you're posting code, if you post code that's got unusual ways of solving a problem that are identical to the ways that other students have solved that problem, and that there are other little ways that we assess the code, you run a real risk of being detected, referred to the SACO, and it's unpleasant for everyone. So my advice is really simple. Don't cheat, don't collude, don't plagiarise. We want to know how much you know, not how much you can extract from other sources. So, overview of the final exam questions. There's 4 questions, and we've written them as 10 marks per question. Where there's questions, sub-questions, parts A, B, C within a single question, the marks for those are indicated. So there's a little catch around the 4 questions. We wrote the paper with 4 questions in mind for equal marks per question. It doesn't mean that the questions are equal difficulty, and I'll talk about that in a moment. But most importantly is that while we sent our exam paper off to examinations to upload into Blackboard on our behalf, that's the way the system works, it may be that the exact format of the exam will differ from the 4 questions, because it might not be possible to fit the exact 4 questions into neat questions that fit within the Blackboard constraints. If it happens that the exam is different from the one that we submitted, I'll let you know in email and Blackboard announcement and Discord if that's the case. But keep in mind that any changes will only be a reorganisation, a shuffling of the questions 1 and 4 that I talk about today. So it's not like we're going to remove a question. It's not like we're going to add a question. It's not like we're going to assess material that I've not talked about today. It's just that the format that you see on the day, and the day is Tuesday, the 8th of June, it might differ somewhat. I'll give you a heads up on any sort of change there, but I consider that a detail. I think it's much easier for you to think of the exam as having 4 questions and equal marks per question. However, it's unlikely that most students would find all questions equally easy. And as a general guide, question 2 is a bit harder than question 1. Question 3 is a bit harder than question 2. And question 4 is harder than any of the questions that come before it. And I say that not to scare you, but to be up front. Questions 1 and 2, reasonably straightforward. Don't be surprised if some of those marks in questions 1 and 2 seem pretty easy. Don't be surprised if parts of question 4 you think that's pretty tough. I might be able to solve that question, but I don't have enough time. That's okay. We want to know what you can do in the time available. Oh, I should say the 130 minutes. Let me just back up. It's a bit odd that you get an exam for 130 minutes. I think of it as a 2-hour exam with 10 minutes to do the various uploads that are required. It's very unlikely that you would answer the question by completing all the questions and then upload the questions at the end, your solutions at the end. In fact, I'd guide against that. But the university rules are what they are. You've got 130 minutes. So the exam opens at 2 p.m. and it closes at 10 past 4, 130 minutes later. So it's like 2 hours plus 10 minutes for upload. So we've only had one question in the questions lectures channel so far, and it was a beauty. Do all the 4 questions require uploading some written Python code? And the short answer to that is no. Question 1 consists of 10 multiple choice questions, and I've got a sample question for you in a moment. And for example, we could ask you, if you were given some Python code, to identify if a particular piece of code has a coding error, what's the output when the code runs, maybe other styles of multiple choice questions. So to Owen, your question about, so within the 130 minutes, may I load up answers? Yep. Thanks, Sarah. That's wonderful. So 10 multiple choice questions. I'll give you a sample of what a multiple choice question in this course looks like. We haven't seen them before. We could give you some code. There's a little story here. A student wrote some Python code below to calculate the sum total of all entries in an array. What happens when the code is run? And you're given 4 options. Notice that the code fragment that's given to you there is given to you as an image. What that means is that if you want to answer this question by typing the code into PyCharm, and actually the question asks what happens when the code's run, one solution strategy for you is to type that code into Python, into PyCharm, and run it, see what happens. That's completely valid. That's a completely valid strategy for you to adopt. I wouldn't recommend it for all the questions because there are 10 questions, and nominally, if it's worth 10 marks, you should be spending about no more than half an hour on this question. In fact, I'd recommend that you spend less, so you give yourself more time for the questions that follow. You probably haven't got time to enter the code into PyCharm and run each of the cases. So you're welcome to do it. There's no way of us knowing, or in the end, it's a multiple choice, A, B, C, or D. No way of knowing, no way of stopping, and I wouldn't even recommend that you don't. Except if you do, you're probably going to run out of time for later questions. So what happens when the code's run? And there are 4 options there. The first one is that the PyCharm complains about a syntax error. The next 2 options are that code prints a total of 5, or the code prints a total of 6. And the final option is the code gets stuck in an infinite loop. So what happens when that code's run? You want to pop an answer to me in Christian's lectures? Get a 6. Let's have a look here. Oh, we've got different answers. Sean says 6, James says 5, Joel says 5. Syntax error. Oh, excellent. We got 3 options out of 4. Okay, so we've got a variety of answers. Okay, let's have a look here. There's a difference. So I can see there's a range of, thanks for those answers coming in now. There's a range of answers. Some people are saying a syntax error. Some people are saying, okay, so it was out of bounds for array with length. Okay, so we've got a variety of answers here. Okay, so I'll make a general point and then we'll actually run it in PyCharm and have a look at what happens when we run it. I'll answer your question in a moment, Emma, or maybe Sarah can. There's a difference between what the code actually does and what we want it to do. We want it to add up the numbers in the array. And if you add up the numbers in your head in the array, the -1 + 3 is 2, +5 is 7, -2 is 5. So the target number is 5, although when we actually run it at 6, and the reason is that the array index starts at 1. And we know that in Python, array indices start at 0. So we should be, we're actually going to start counting at the 3 entry rather than the -1 entry. So 3 + 5 is 8, -2 is 6. So it'll actually produce 6 rather than the correct answer, but let's just check that. Now I've got the advantage of having the code available to me. And so if I run this code now, if I run example question 1, I get the answer 6 displayed. But I've had the advantage of having the code because I wrote this little fragment of code, this little program. So the correct answer is C. The code prints the total 6. And the reason is that the first entry in the call to the range function should have been 0 in order to run, to calculate the sum of 5. But the code itself had a 1 there. And so if we run it, it actually produces 6. So what are the general observations that we can draw at this point? The first one is that if there's a little story about a student wrote some code, what the code's meant to do and what it actually does are 2 different things, or don't have to be the same thing. Asking a question about what happens when the code is run, we're actually asking you in this question about, do you understand about array indexing in Python? I haven't asked that question as in, you know, what array index does Python start at? Is it 0 or 1? There's a 50-50 chance. We've given you a little backstory and given you an opportunity to demonstrate your knowledge. And as I say, writing the code into PyCharm is completely valid. You'll probably run out of time if you take that though. Okay. So that's the style of question for question 1. Now there was I think Emma asked a question that Sarah's answered. Will we be able to know our multiple choice mark for the final exam immediately, or will it be hidden from us? Yeah, Sarah's answered, you won't, because the last 3 questions are marked by hand and we can't release the grades until they've been approved by the school assessment board. Yep. And Tyler asked, why do all the numbers in the array have dot points after them except for the first one? Are they all integers or all floats? Great question. Should we, Sarah's going to answer that question, but maybe we can do an experiment with that online. It's a great question. So let me just go back to it. Let's see what happens if we remove the dots from all the entries apart from, including the first. So let's run that now. Notice how the answer displayed is 6. It's an integer. So Wonderful. Sarah's answered, as long as one entry in the array is defined as a float, all be float. So at the moment, the array that's created is an array of integers. As soon as we could put 0.0 or point in one of them, Python says, it can't be an array of integers because at least one of the numbers is a float, therefore it has to be an array of floats. So if we run the same program again now, it gives an answer 6, which is really it's subtle, but it's actually quite a nice feature of the language. What's happening behind the scenes is that Python's deciding to create the array of the certain type in order to accommodate the data that's given, and we don't have to actually force it to be anything unless we want it to be. But that's a great question, Tyler. Thank you for asking that question. So, second question. Question 2, I've given some general scope of the question, and in the information I'm giving you here, I'm not necessarily saying that a question would ask for all these points, but it's the broad scope of question 2 is to write some Python code to evaluate an expression at a single value of X, or at a range of values using loops, or a range of values using a vectorized solution, or to generate a plot, putting labels on the plot. That's the sort of scope of question 2. So a sample question 2, it's not the actual question 2, but a sample question 2 would be write a Python script which plots the following function given to you as a mathematical expression using 200 linearly spaced time points. Your script should use a value of A, display the date in the title. What I'm going to try and do for you now in just a few minutes is not just give you a sample solution, but to work through the process as if I was doing it in a quiz. Let's do that here now. I'll bring up this file for you in a moment. Let me just create this, and I know you can't see anything at the moment. I'll bring it up for you in a sec. Excellent. Okay, so let me just remove this and let's do it live. So what I'm going to suggest is question 2's got enough going on in it that I don't expect you to be able to do it straight up. So in one hit, I always like to import NumPy is my first line. We're going to do some plotting, so we probably want to do let's have a look here. Give me a moment. Sorry. I want to do this live. That's the command I want here. That's the one I can never remember top of my head. Okay, so that's the mouthful one. So that gives us some plotting. And so what's the question asked? Write a Python script. Let's say we need T, and I'm going to use the linspace function. We want, it starts at 0 and finishes at 5. I'm going to ignore the instruction about the number of linearly spaced time points to start with. And then I'm going to evaluate that function expression. Minus a t, and then a times t, and then I remember I haven't defined a, so a needed to be value 2. Here's what I would actually do if I was answering this question. This is what I actually did when I created this code. The expression you see there in front of you is not the correct expression for F, and the number of time points is not the right number of time points. But just to make sure I'm on the right track, I'm going to run this code. Okay, so we're underway. We've defined a time base. We've evaluated the function expression, and we've plotted a function f, but it's not the right one yet. We haven't put today's date in the title, so that's not a correct answer yet. So what we'll have to go back and do is look at the expression. So let me just bring up the expression for you. It was either the a minus t times the sum of a sine and a cos. So now I'm going to enter those times brackets np dot sine of something plus np dot cos of something, and the somethings were 5 times t and 10 times t. And now I'm going to run that code again. Okay, so now we're getting something displayed. Okay, looks a bit wonky, but that's what it is. At this point, I would go back and the question asks us to use 200 time points. And at the moment, Python default or PyCharm defaults to 50. So we need to specify this argument, an argument here, which tells us how many time points to put in. Now, at this point, I would go back to my lecture notes or your notes or an assignment question or a lab question and check the number of the way that the syntax for doing it. But it happens to be this one here, num, tells us how many points we want to use in the function. I don't expect you to remember it, but I expect you to know how to find that information. And this is a great example of an open book exam. It means I can ask a question which asks you to do exactly this, use 200 linearly spaced time points without asking you to memorize some what the arguments are for the linspace function in the NumPy library. If we run that now, we get something. Okay, it looks like a nice looking function there. I don't actually know it's correct. I'm just trying to implement as the assignment said. And now I think we're almost done, except we needed to display today's date in the title of the plot. So let's do that too. Plot, title, and what's the date today? The 27th of May. If we run that, done. We're allowed to use any Python library, and then we're asked to upload the Python code and the plot image. And so we could upload the Python file and we could upload the plot image. So you should be prepared to know how to take a screenshot or use another way, other way that you like of generating a copy of that figure and uploading it. And otherwise that would be a correct solution. And so it was actually quite an authentic way that I developed it, because after the very first step, I'd forgotten the syntax for the import matplotlib.pyplot. I always forget that. I can never memorize it. Don't have to memorize it. I went back to some other code that had that statement and I cut and pasted into my solution there. Completely valid for you to do. Trying to memorize that sort of syntax is a waste of valuable brain cells. Know that you can look it up if you need to. And in the space of, I didn't set the timer, but I think it took me about 6 or 7, 8 minutes. I've answered question 2. If that was the style of question that you'd be expected in the final exam, you nominally got half an hour to answer that question. So you've given yourself a little bit of extra time to answer some later questions. So the scope of question 2, writing basically function evaluation and plotting. Whether you want to use loops or a vectorized solution that I did here, choice is up to you. Generating a plot, putting some labels if you need, title, grid, plot, and so on. The particular question I need to ask you to put the date in the title. The exam might ask you to put X labels, Y labels, other information on the plot. So that's question 2. Let me just check the questions. Tyler makes the point importing matplotlib for Mac users is also different. Great advice, Tyler. Great observation. Yep. I'm quite comfortable going on record that generating a plot is part of question 2 in the exam. You should therefore, if you're using a Mac platform, then the particular command that you use at the top of your file needs to run on your platform, and it needs to do that because you need to generate the plot, the image that you upload in the file upload box in Blackboard. So let's have. I think Sarah's answered the other questions. Will adding the date be something in the test, or just for the example, just an example? Okay, so the broader point, Ben, that I'm asking about the date is, do you know how to generate a plot that's got a title? The particulars of what go in the title, I'll leave for the final exam, but yep. I'm not actually asking you to use the any sort of date function. Just type it in as a string. Let's have a look. So Owen's asked a question. For some of the questions, do we have a short answer as well, or is it just multiple choice and code? And Sarah said, from memory, there's at least one short answer where you have to type a number into a box. That's correct. That's correct. Is it question 3? It's question 4. Question 4 will require a mix of uploading numerical values and Python code. So question 3, the general scope of question 3 is to write Python code which uses flow control, for loops, while loops, and the various 3 versions of the conditionals: if, else if, and if, else if, else. They're all coming up in the assignment, for example. So what I'm not going to do, I'm not going to develop a solution online for you, keeping in mind that the questions here are getting progressively more challenging, and therefore the information, the explicit information I'm giving you about what's in the questions is actually going to step back. But I'm being clear about the scope here. The general scope of question 3 is, can you write a Python script which solves a problem using iteration, either for loops, while loops, bit of both, using some conditions. So here's an example. Again, it's a sample, not the actual question, but it gives you a sense of what I mean by solving a problem. I've given you an expression there, which is a mathematical expression that adds up the sum of cubes. We've seen squares before, but this is a sum of cubes up to some value of n. The n's probably going to be a variable in our code. Write a Python script which uses a for loop to calculate that sum when n's equal to 5. Okay, so then I'm asking, can you write a for loop that runs from 1 up to n, where n's given value 5, and keep a running sum of values of the loop index raised to the 3rd power. Okay, so that's reasonably straightforward. Second part of the question, use a while loop to calculate the largest integer n such that the sum is less than 1,000,000. That's going to require a bit more care. All I'm going to say for your study purposes is I'm not going to give you the code, I'm not going to upload code. I'm not going to develop a solution for you live here online, but that would be if you could answer that sample question there in question 3, you'd be very well placed to answer the question in the final exam. And I think this goes to the question that was asked just a few moments ago in Discord, which is about what you have to upload. In this case, we're not asking for I'm not actually interested in the numbers, we're interested in the code. So this would be probably either 1 or 2 programs. I'd be clear about that in the final exam, whether you needed to write 1 program which solved both problems or 2 separate, and then upload your Python code into Blackboard. And you've all done that before in the Assess Labs, where you right click, cut and paste, upload some code. In this case, in this particular sample question, I'm not requiring numerical values, just the code. And so that's certainly the broad scope of question 3. Writing Python code which uses flow control. This particular question, the sample question here, doesn't use any conditions, but it's possible to embed those conditions in a while loop, for example. So that would be a variation on a while loop here, but this one here, use a while loop to calculate the largest integers such that the sum here is less than 1,000,000. As you go to each larger values of n, the sum gets bigger and bigger, and the question is, what's the biggest integer, such that if you add up the cubes up to and including that integer, you get a sum that's no more than 1,000,000. So that would be a great study question for question 3. Final question. I'm going to give you even less information, but I'll capture the broad scope of what's in question 4. Keeping in mind that if you're getting more than 3/4 of the grade for the final exam, you're really, if you look at the details of the course outline, you're demonstrating knowledge that is very comprehensive, and therefore I'm not going to give you too many hints about the specifics of question 4. But the sorts of things you could be asked in question 4 include some combination of reading data from a spreadsheet. We did that way back when. Sarah showed you how to read data using the Pandas library. Reading data from a spreadsheet is a great way of writing an exam question, because we can provide a level of randomization that means that different students will get slightly different problems to solve, and therefore different answers to upload. Solving a problem by writing a Python function. We haven't talked about that. None of the previous questions have asked you to write any code that involves a Python function. So that would be a great point to expect the question that requires you to write a Python function. We looked a few weeks ago at making sense of data by fitting a curve to it, starting off with a straight line, so-called linear regression. And then we looked at some extensions of that where we fitted low order polynomials, parabolas and cubic polynomials to data. So this is the idea of being able to use the curve fit function, which finds the curve of best fit that describes a given data set. We also spend quite a bit of time in the course on numerical integration. It's a really important topic in the course. So numerical integration, you could reasonably expect in question 4. Not going to guarantee it, but it's if it was going to be anywhere, it would be in question 4, because it doesn't look like it's in scope for any of the earlier questions. You might get a question on integration in question 1, but who's to say? And then finally, one of the other topics we spent quite a bit of time on was finding the roots of an equation using the secant method or the bisection method. Question 4, plenty of scope for including some or all of those activities in question 4. And then in question 4, you're asked to upload both numerical values and Python code. So I think in question 2, the sample ones I've given you here, you upload Python code and a figure. Question 3, you upload Python code only. And in question 4, sample, uploading numerical values and Python code. So if you think about, I think this goes right back to the first question I was asked this afternoon. What do you actually upload as part of your Blackboard submission? It's a mix of multiple choice, numerical answers, and Python code. Okay, have we got any questions that I haven't touched on? I think I've kept up with those, or Sarah's kept up with them, and I think I've covered them all. Oh, James asked a question, yeah, but ensuring that you do a pip install matplotlib, absolutely. So let me go right back to an earlier point I made. You will be asked to write Python code in the exam. The overwhelming majority of the exam, questions 2, 3, and 4, all ask you to write Python code. So you should be ready to go on the day with the best PyCharm setup that you've got. All your libraries, pip installed, your Python, your PyCharm installation, all ready to go. If there are issues around Mac platforms, I'm telling you now, you will be asked to generate a plot, at least one plot in the final exam. So you need to do that. The thing that Tyler suggested, import matplotlib and something about TKAG for Mac users. Thanks for posting that there, Tyler. Appreciate that. So I'm completely transparent here. You will be asked to upload a plot, and so be prepared. So anything you need to do to get PyCharm ready to go, that's what you should be doing. Okay, we've only got a few minutes left. I want to finish before 5, but if there are any other questions, don't feel like this is the last opportunity to ask questions, but it is an opportunity you can ask questions live here now. We'll set up a channel, especially on Discord, for discussions around the final exam, so you can be asking questions right up until sometime before the exam actually kicks off in about, 10 days or thereabouts. See if there's any other questions coming through. Lachlan asks, are we allowed to use our own modules we've created and upload them separately in our exam? That's a good question. Okay, so I'll start with the intent. The intent is that the code that you write to answer the questions in the exam is yours, and the exam's been written on the assumption that you could start from scratch and write write answers to all the questions. Knowing what I do about the exam, because I wrote it or co-wrote it, there would be advantages to having some code ready to go. On the other hand, any code that you would need would be very readily accessible from files that you've already got. I'm going to take that question on notice, Lachlan, and I'll answer it. I don't want to give the wrong answer, but I don't think you'd need it, but I don't want to preclude it either. So Cooper asked the question, what do you mean by numerical values, numerical integration? I mean a number. Type a number into a box. What's the value of this function evaluated at point t equals 5? You get a number and you type that number into a box. Yeah. Yep. Thanks, Sarah. That's beaut. Yep. Okay, I'll make it just on 5 to 5. Thanks so much, everyone, for your questions. We'll set up a channel specifically around the final exam. For students preparing for it, but it won't be a channel that you can monitor live on during the course of the exam. But if there are questions around style and content and expectations and how to prepare for the exam, that's where I'd like to answer those questions for you and have you to be able to answer each other's questions in an exam related channel. Yeah, okay, thanks, Sarah. That's a good answer to Lachlan's question there about are we they'd use our own modules created. Yep. Yep, good answer. Okay, wonderful, everyone. Thanks very much for your attendance. We won't be having a lecture on Monday, so this will be our final lecture for the course. We'll be in touch through our usual communication means of our all class emails, Blackboard announcements, and of course, Discord. Good luck as you finish your preparation for your exams and also for the assignment that's due on Monday morning. We'll be in touch electronically. Until we catch up next, I'll say bye for now.